Hello and welcome to Train Signal. This is video number 5, Using Linux, Part 2. This is part of Fast Track CBT Video, Linux Networking and Administration. This is our table of contents for video 5. In this video we're going to cover a number of Linux Plus objectives, but these objectives are very important not just for someone who's wanting to get Linux Plus certified, but also for anyone who just wants to learn how to use Linux. We're going to do a lot of commands at the command line. We're going to learn about Unix file permissions, file ownership, how to change ownership, how to change group membership, how to control read, write, and execute access on files. We're going to learn how to configure the X Window system. We'll learn about environmental variables. You'll find out how to configure the default permissions for any new files you create. And then you'll learn how to search through directories using find, grep, and other programs. So with that, let's get on with learning how to use Linux. First off, we're going to talk about Linux Plus Objective 2.3. It says create files and directories and modify files using CLI commands. So this is very important for anyone who wants to learn how to get around Linux at the command line. So what we're going to cover here are hidden files, the colored listings when you do an ls command, recursive listings, different forms of wildcards other than the asterisk that we already learned. We'll learn about the make directory command, remove directory command, the -p option, which works like delete tree in Windows, and then we're going to point out how with RM there's no trash can. That's very important. So let's go over to our Linux server. So here we are on our Linux server. So we're going to go down the list, and I'm not just going to talk about those things, but I'm going to show you exactly how they work at the real Linux command prompt. So if I go and I open the Xterm program or the windowing terminal, so this is our command line prompt here. This is the bash shell. First thing we want to demonstrate is hidden files, how hidden files work. In Linux, a hidden file is anything with a dot in front of it. So if I type ls, I get to see these files here. There's not a lot of files in my home directory. If I type ls-a, the A stands for all files. So ls-a shows me a lot more files. Now those other files that I see now, these are configuration files, most of them, or history files, and they didn't show up before because they had a dot at the front of them. You see the dot that's in front of every one of those files. So that means they're hidden files. And for an example, one of the hidden files is the bash_history file. This is the history of all the commands that we've done on this Linux server as this user. So this is a per user file. So if I cat stands for concatenate. We're going to talk about that in a minute. If I cat the .bash_history, you get to see a list of all the different commands I've been doing on this Linux server as this user. So that's what a hidden file is. A hidden file is any file that starts with a dot. And it's very easy to make your own hidden file. You just put a dot in front of it and it's a hidden file. So with that, let's go back and let's look at the colored files. Colored files we talked about in a previous video, but I just want to make sure that we fully cover it. If I type ls, notice that the desktop file here is colored. It's colored blue. And that's because that's a directory. If I type ls-l, I can see that the desktop file here has a D over here on the left column, and that stands for directory. So that's a directory, and that's why that's blue. Now, other files will show up as other colors. There's a command called dir colors, which can be used to adjust the colors of certain files. And it's just based on what type of file it is. Is it a directory or is it a file? And if it's a file, what extension does it have? So you can configure, say the .log files to have be colored in red. But by default, there's a lot of different colors for different file extensions. So when you're doing directory listings, you might see multiple colors of files, and that's just what those are. They're there to help you identify what is a certain file type. And to me, the most useful one is a directory being blue. So that way when you just type ls, I can tell, oh, desktop is a directory, so I can type cd desktop, and I can go into the desktop folder. Whereas otherwise, I might not have known that that was a directory. The next thing I want to talk about is recursive listings. Let me clear the screen. And I'm going to go back one folder. And then I'm going to clear the screen again so we can start off fresh. So we're back in our home directory. We're going to talk about recursive listings. A recursive listing is usually a -R option on a command. Not all commands have a recursive listing, but an example of a recursive listing would be ls-r. ls-r shows you every file in the current directory, and then for every directory underneath that, it shows you whatever files are in that directory, and so on and so forth. So notice here it showed us that the current directory had these files in it. And then below that there was a directory called desktop that didn't have any files. So if we go to the root directory, cd \, and I type ls-r, I'm going to get many files because that's going to show you every file on the whole system. So I'm going to pipe that to more, and we're going to talk about piping in a little bit. Piping it to more just makes it one page at a time. So if I press enter, first it lists out the root directory here and all the directories underneath it. So if I push space, it shows me the bin directory, and here's all the files in the bin directory. Then it shows me the boot directory with all the files in there, the boot grub directory, the files in there, the boot lost and found, the dev directory, lots of files in there, and then so on and so forth. It just keeps going here, down into the directory tree, showing you every file and every folder that's on this hard drive. So that's an example of a recursive listing. You can also use recursive listings on the rm command. If you do an rm-r* as root from the root directory, you'll delete every single file on your entire system. rm-r is a very dangerous command, probably the most dangerous command you can do on a Linux system. And it's recursive. That's what the -R is. So it goes through every directory and every file, and it deletes every one of them. That's not something you want to try out for yourself. Now let's talk about wildcards. I'm going to clear the screen again with the clear command. So here we are at the root file system, and what I want to demonstrate are wildcards. We talked about the asterisk wildcard and how it represents any characters, and you can put it at the start or at the end of a directory listing or some other command that you're trying to do on files. There's the question mark wildcard, and that's what I want to talk about first. First, let's go into a directory where there's a lot of files that we can demonstrate this on. I'm going to go into cd/user/bin and type ls. Okay, there's a ton of files in here. So what I want to do is demonstrate the question mark. So it represents a single character. I'm going to type ls and then z with 1, 2, 3 question marks. So that represents z in any 3 characters after that. So I'm going to press enter, and notice we got 2 different commands, zcmp and znew. They both start with z and they both have 3 characters after them. So that's how the question mark wildcard works. Let's try another one. Let's try lsz question mark grep. That also gave us 2 different commands, zegrep and zfgrep. So you can see how the question mark wildcard can be used to represent a single character. Now let's try the brackets. If you do ls and then say I do z left bracket and then I do a through f right bracket and then grep. So this should give me anything that starts with z, then has an a through an f, and then ends in grep. Or an a, any letter in there, any letter in between the brackets, a single letter though, either a, b, c, d, all the way through f. So I press enter, and we get the exact same thing. You see how that works. So if I hit up arrow, I can go back here and repeat my previous command. Let's do A through C. Well, it didn't find any files that time because there are no files that start with A through C. See how that works? What if I do E through F? It gives me the same two files again. And you see how that works because here's the E and here's the F. So A through C didn't represent any of the two files that were similar to that. There were none that had an A through a C in the second position there. So that's how the brackets work. And you can use this for a range, any range of letters or any range of numbers. You can put numbers in there as well, like 0 through 9, however you want to do it. So now let's go and let's learn about directories. I'm going to type CD. I'm going to go back to my home directory. That's for the root user, that's /root, the root home directory. Now let's learn about making directories. I'm going to clear the screen. So to demonstrate how to create and remove directories, first off we're going to start off by creating a directory. To do that, you use the mkdir command, and that stands for make directory. So I'm going to create a directory. I'm going to call it fishing. So if I type ls, you can see I just created a directory called fishing. You can tell because it's in blue right here. So that's our new directory called fishing we made with the mkdir command. Now if I go into that folder or directory and create a file, I'm going to create a file with this command, echo hello, and redirect it to a file. Now don't think I just skipped over redirection there because that's an important topic, and we're going to be talking about redirection in just a second. But right now we're just going to use this echo command and redirection to create a file called hello. So if I type ls, I can see my file there called hello. I'm going to go back one directory, and now let's try to remove that directory. If I do rmdir, that stands for remove directory, and then I type the name of the directory, fishing. So if I press enter, it didn't work. It didn't work because the directory is not empty. That's because there's that file inside called hello. So before we can remove the directory, we have to first remove the file. So I'm going to go into the directory again, and I'm going to remove the file with the rm command, rm hello. It says, are you sure you want to remove this file? I'll say yes. I'll do an ls, and the file's gone. So we can go back one directory. I'll use the up arrow key here, and we'll go to the command that says rmdir fishing. I'll press enter, and we just removed the fishing directory. Let's do an ls to make sure. Yep, it's gone. So now let's try out something else. Let's make the directory again, and let's go inside the directory. Let's make our file in there again. I'm using the up arrow key here, and I just created the hello file. Let's go back and show you another option. Another option is rm minus r, capital R, for recursive. It'll delete everything you specify and everything below that. And then there's the F option, which says don't prompt me, force it to delete everything. Don't ask me yes or no. So now I'm going to type fishing, which is the folder we created, press enter, and voila, it removed it. Let's type ls, and it's gone. It deleted the directory and the file underneath. So that's a very powerful command. Now let's try out another option. Let's make the directory again. We're going to go into the directory, and I'm going to make another directory called fishing2. So we're in the fishing directory, and then there's a subdirectory called fishing2. So I'm going to go back to our home directory, and we're going to use the rmdir minus p command. This is kind of like recursive. It'll delete multiple directories in a tree, kind of like a delete tree in DOS. But the catch still is with rmdir that the directories have to be empty. So you can't do this with directories that have any files in them. So I'm going to do rmdir -p phishing / phishing2. And it just deleted both directories. So that's how that works. Be careful with the rm command and rmdir command because there is no trash can. When you're working here at the command line, there is no trash can to get these files back. If you do this at the GUI interface or in Nautilus, it will put things in the trash can. So let's close out this window and go back to our slides. Alright, now let's talk about searching. Searching is a very important topic in Linux, and that's because there's so many files and so many folders, it's hard sometimes to find what you're looking for. So being able to find what you need when you need it is a very important skill to master. And that's why they mention it specifically in Linux Plus Objective 2.4. Execute content and directory searches using find and grep. And we're going to talk more than just about find and grep. We're going to talk about other utilities as well. So let me scroll down here and let's talk first about the find command. The find command has tons of different options. These are just a few of the different options, but basically it goes through all the files in the file system and it looks for something that you specify. So if you say the name of the file is this, or the permissions are this, or the size are this, or it's owned by this person, it looks for all those criteria. So that's what the find command can do, and it's very powerful also to take output from the find command and send it to some other program. So we'll use the find command here in just a second. I'll show you how it works. The next one is locate. Locate is less sophisticated than find, but much faster, and that's because locate uses a database. There's a database that's created periodically by a command called updatedb. Updatedb runs periodically by the cron daemon. The cron daemon is a program that executes things in batch processing. So it can execute things on a schedule, every Sunday night, every Monday at 5 o'clock, whatever you tell it to. But by default, this updatedb program runs under the cron daemon and it updates the locate database. So because it has this database, it knows where all the files are on the hard drive. It can find files much faster. Now the catch is it can only locate things that have been updated in the database. So if you just created a file 5 minutes ago, chances are you're not going to be able to find it with locate because the database hasn't yet been updated. So we'll see how locate works. Then we're going to talk about where is. Where is searches only standard binaries. So directories like bin and user bin and user sbin, those different directories, that's what where is searches. It only searches for programs that are in those directories. So if you're trying to find a command or an administrative command, where is a program that you would want to use. Then there's grep. Grep looks through some text output and filters it. So an example of using grep is you do an ls and you send that or you redirect that to grep. Grep takes the output and you say, from the output, I only want to see things that have the word fish in them. Well, grep would look through all the output and only give you the lines that have the word fish in those lines. So you'll see how grep works, and we'll go through those different options. Then there's cat. Cat takes text files and displays them on the screen, or you can take the output from cat and you can send it to something else. So you can take one file and combine it together with another file. That's what cat was originally designed to do, was concatenate things or put things together. Cat can also create a file if you use the dash option, and then you redirect it to the name of the file. There's some commands called more and less. More shows you things one page at a time. It also has some searching features. Less is very similar to more, but it has some different options. Then there's tail. Tail shows you just the last few lines of a file. There's also a program called head. Head shows you the first few lines of a file. Then we're going to explore the power of pipes and redirects. A pipe looks like this. Let me show you what a pipe looks like. Looks like that. The pipe symbol is the symbol that's just above your backslash key. So if you look at your enter on your keyboard, just above that is the backslash. If you hold down shift and hit backslash, you're creating that pipe symbol that's right there on your keyboard. So we're going to be using that in Linux to pipe information from one command to another command. That's what pipe does. So say I have ls, I want to pipe that to grep and use grep to take the output from ls and search through it. Well, to connect those two programs, you use this symbol. It's a pipe. It's called a pipe. A redirect is a symbol that looks like this. It's the greater than or the less than sign, depending what direction you want to redirect things. So, like when we used our echo command, we did echo hello. So normally echo hello would just send the word hello to your screen. But then I redirected that to a file. So it created a file on the disk that had the word hello in it. So that's what a pipe and a redirect can do for you. And I'm going to show you some examples of how that works with these different commands here. Cat, find, ls to grep, ps to grep. Different programs can be combined to do some very powerful things. So with that, let's go to the Linux system over here, the real live server, and let's do some of these commands. Alright, so I'm going to open up my terminal window again. Now, first off, we want to use the find command. And I'm going to try out the name option. So say I go to cd backslash, that's the root directory, and I say find minus name, anything that is named bin. That's what I'm trying to find right here. So if I press enter, it starts searching through every directory on the hard drive, looking for anything named bin. So you can see it already came up with a few things here. There's a folder called bin, another folder called bin. By the way, it's going to find folders as well as files. And looks like we got a hard link count is wrong, blah, blah, blah. So that's not important really to us. Let's go into our home directory by typing cd, and let's try it again. Let's do find minus name install.log. And that happened really quickly because there weren't very many files for us to find. So it found the file called install.log. Let's go into the etc directory and let's find anything named yum. Well, it found 3 things named yum right there. So you can see how this minus name works. Okay, let's go in, we're in etc already. Let's do find minus perm, perm, and perm stands for permissions. So here I'm looking for permissions, and we haven't talked about how octal permissions work yet in Linux. But so for now, just take my word for it. I'm going to type in 700, and that stands for any file that's where the owner has full access, group has no access, and everyone else has no access either. So 700 is an octal permission, and we're going to talk about octal permissions in this video. So basically all you need to know here is I'm trying to find a file that has certain permissions. So if I hit enter on that, it tells me these files right here underneath the etc directory have that permission set on them. So very powerful. Okay, another thing, let's go into /home. And we haven't talked about user IDs yet, but every user on a Linux server has a unique number that represents their username. So these user IDs are in the etc password file. So if I cat, remember the cat file is short for concatenate, and it's what's used to view files. If I cat /etc/passwd, that's the password file. That's where users are stored, and we'll talk about that in future videos. But if I cat that out, the first number here after the username is the user ID number. So Jim, the user we created when we installed Linux, has a user ID of 500. So I'm here, I'm in the /home directory. I can use the find command to find anything that has a user ID of 500. So I'll press enter there, and it found a handful of files. It found a directory, and then underneath that directory these configuration files that belong to Jim. And it found those because they all have the user ID of 500. So if I do an ls-l, you can see here these files are owned by Jim, and Jim's user ID is 500 up here, which we found in the Etsy password directory. So that's how find works. One of my favorite uses for find is to go into a directory like Etsy and do find minus print. Find minus print just prints out every file it finds. And then I pipe that. Remember we talked about pipes, how they're used to connect from one program to another program, to grep. Now what grep does, we haven't talked about grep yet, but it's a great time to bring it up. Grep looks for text output, and it gives you the line that contains the piece of text you tell it to. So here's an example of piping find and grep together. So I'm going to find every file in this directory, and I'm going to grep for yum. So if I press enter there, it shows me every file or every folder as well that also has the word yum in it. So you can see every one of these has the word yum. So I connected the output from find to grep. Now let's look at the output of just find minus print. That's every file in every folder in the Etsy directory right there. It scrolled by very fast, but it was. So what grep did was it looked through all those, it found only things that had the word yum in them, and it showed them to me. So now let's talk about locate. Locate, we said, is less sophisticated but much faster than find. So if I type locate yum, notice how quickly it gave me that output. And it gave me a lot of different files here all over the system in all different folders. So it did that because it has this database. The database is updated by the updatedb command. And locate's a great program. The only catch is, like I said, it won't show you a program or a folder or a file that I just created. So if I go back to my home directory and say I make a directory called David, and then I do locate David, it didn't find anything at all. But if I do find minus name David, it finds the file, because find looks real time, whereas locate goes to a database. Now let's look at where is. Where is only searches through binary directories like user bin, user sbin. So if I type where is ls, it tells me that ls is stored in the bin ls directory. It's also found, or some variants of it, not the actual program, but some zipped versions of it are found over here. Actually, zipped versions of the man page for ls are found over there. So I know that bin ls is where the ls program is. So if I go to /bin and I type ls, you can see it finds ls, and it's colored that color because it's an executable program. So that's what where is does. Now let's look at grep. I'm going to clear the screen here. So grep has a lot of different options. To learn all the different options for grep, you can type man space grep, and you can read the man page to your heart's content and find out really how complex grep is and everything that it can do. It's a very powerful tool. To demonstrate how grep works in its most basic form, I'm going to change to the Etsy directory and just type grep local space hosts. What this does is it looks for the word local in a file called hosts. So I know there's a file there called hosts. I know inside hosts there's a line that has the word local in it. So that's what grep's going to tell me. Press enter, and it looked through the entire text file called hosts, and it found any line that had local in it, and it printed it out. So there was just one line. Another option for grep is -f. -f is where you have a text file with words in it that you want to search for, and you can actually have grep search your entire hard drive for the words that you had in this text file. You can use -i to ignore case, and you can use -r for a recursive search. So let's try that. If I do grep -r local and asterisk, what it'll do is it'll look through the etc directory for every file in every subdirectory in the current directory and look for any file that has the word local in it and print out the line. So let's try that. Wow, it finds lots of files there. Let's do a Control-C and stop that output. And let's be a little bit more specific. Let's look for the word localhost. How about that? Okay, so it doesn't find as many files. Here it finds some binary files that it can't look in. It finds some other files, actually lots of other files, that have the word localhost in them. And it just keeps on going. So that's another example of how grep works. Okay, it finished there. So every one of these lines contains the word localhost, localhost, localhost was in every one of these lines. So that's what grep can do. Now to me the real power of grep is taking output from something and piping it to grep. So if I did ls and I want to find anything that has the word host in it, I can grep for host. So what I found out right there is in the etc directory there are 5 files that have the word host in the name of the title. So that's pretty cool. That's pretty handy. So if I'm looking for a certain file, I can do like ls-r, I can pipe that to grep, and I can look for hosts. So there it did a recursive search, and it found, went through any subdirectories as well, and it pulled out any files that had the word host in the file name. So grep's very powerful. You can combine it with other tools. For instance, find. I can do find -print, pipe that to grep, and look for hosts as well. So it's another way of doing what I just did with ls. I can do ps commands. We did the ps, which is process list commands, -f, and I can grep for init. So instead of a long listing from the ps output that could be many screens long, I used grep just to look for anything that had the word init in it. And actually it didn't find anything. What it did find was my program running grep init. So let's try it again. Let's do ps -f. Here we go. Let's do ps -ef. There we get everything. Okay. Now we see in this list at the top here there's definitely an init. So that was where a mistake was. So if I do up arrow, I can go back here and very quickly I can put the E in this, rerun the command, and I get the real init program right there. So you can see how quickly I was able to look through that output and find the init program. Now it might not seem like a big deal because you're thinking, well, that was just a couple screens long and I was able to scroll up there and just find it myself. But for instance, I've worked on Unix servers where you have over 20,000 processes. So if you're looking for an individual process, grep might be the only way you're ever going to find it. So with that, let's clear the screen. So now let's talk about the cat command. Cat has nothing to do with feline animals. It's actually short for concatenate. So what it's designed to do is take two files and stick them together. But what people normally use cat for is to take one file and display it on the screen or send the output of that file to some other program. So I'm here in the etc directory. If I type cat hosts, I get the output of the host file. That's what's inside the host file. So if I up arrow with that and I pipe it to grep and I grep for a word like net, I get to see any line that has the word net in it. So there was that one line. So cat's used to take the output of a text file and send it to the screen or to redirect it to some other program. So another way of doing it might be I can cat hosts and I can redirect it to root/hosts backup. So I just catted the host file, and I redirected the output to a file called host-backup. Now, I could have just copied the host file and copied it to host-backup instead. It would have done the same thing, but here I used cat to do it. And that's the power of Linux, is there's just so much flexibility. Different commands can be combined to do all sorts of different things. So let me clear the screen and let's talk about the more and the less command. Okay, there's a really long file in this directory called termcap. So I'm going to type more termcap. And you get to see what I'm able to do with more is scroll through this file. So I'm hitting the space bar and I just keep scrolling through the file, and it says here that I'm 1% done down in the bottom. And if I keep scrolling, you can see this is a really long file, and more allows me to go page by page and read things, and it tells me how far I am in the file. If I hit enter, I go line by line, and if I hit Q, I quit. There's another program that's similar to more called less. So if I say less termcap, it's the same thing. I get to go page by page by pressing the space bar, line by line by pressing enter. But I have this colon prompt down at the bottom. So there's actually commands in here I can type. For instance, I can type B and I can go backwards. This is taking me backwards in the file. I went all the way up to the top. So less has actually more functionality than more, strangely enough. So if I type Q, I quit. So now let's look at a couple other commands. One is tail. If I do tail termcap, whoops, got to type it right here, tail termcap, I get to see the last few lines of the termcap file. Not the whole thing, just the last few lines. If I type head termcap, I get to see the first few lines of the file. So this is the start of the file. Tail shows me the end, head shows me the start. So let me clear the screen. And then finally, I just want to point out the power of pipes and redirects. You know, throughout these lessons here, we've talked about different ways of using pipes and redirects. Again, if I type cat termcap and I pipe it to grep and I put in the word term and I pipe that to more, I can see every line in the termcap file that has the word term in it, and it'll be sent to more so I can see it page by page in case there's a lot of it. So if I hit enter, this is only the lines that have the word term in them. So, and then I can scroll through these lines by hitting the space bar. Obviously there's a lot of lines. Let's try something a little bit different. Let's grep for something a little more unique. Let's say VT125. So that time there was only one line that had the word VT125 in it. So that's just an example of using pipes. I can pipe multiple things all together. We also talked about using find and piping that to grep. For instance, if I go to cd \, I can type find minus print, pipe that to grep, and look for termcap. And it looks through every file on the entire Linux hard drive and shows me any files that have the word termcap. So it found the one there in Etsy, right there. Now this could take a while, so I'm going to do Control-C and I'm going to break out of it because I already found what I needed to know. So just another example of using find and piping it to grep. We showed you how to use ls and piping that to grep. Let's go into Etsy and type ls, pipe that to grep, and look for term. So it's like, say I know I have a file in Etsy, it has the word term in it, but I can't remember the name. So I just did an ls, I piped it to grep, and I found any file that has the word term in it. I could have also done that with ls wildcard term and then wildcard. And I got the same files. Notice just a little bit different format. And that's just another example of how flexible Linux is. There's just so many different ways of doing the same thing. I showed you how to use ps minus e, pipe that to grep, and look for certain programs. Like, let's look for term. So there's the GNOME terminal that's running. That's actually what I'm in. So just an example of how to use PS and pipe that to grep. So let's close this out and let's go back to our slides. Okay, we finished talking about searching, so now we can go on to our next section. Okay, in this section we're going to talk about links, creating links. This is part of Linux Objective 2.5, create linked files using CLI commands. Now, before we learn about links, you need to know what an inode is. An inode is a special Linux disk structure that contains information about files. Each file is identified by an inode number. You can see the inode numbers with the ls-i command, and I'll show you that in just a minute. There's two different types of links you need to know about. One is hard links and one is soft links. Now, a soft link is also called a symbolic link. You can think of a symbolic link or a soft link as almost like a shortcut in Windows. You have a little file that represents a shortcut to some other program. So a soft link is just like a shortcut in Windows. Just a pointer to some other file. That file may or may not exist, but it's a pointer. A hard link, on the other hand, is very different, and Windows doesn't have anything that compares. A hard link is an actual copy of the pointer to the inode, the actual pointer to the file. So it's like a duplicate of the file name in some other directory. So the one file exists on the disk, and you have a name in a directory that points to that file. Well, when I create a hard link, I actually copy the entry in the directory and put it in some other directory, or it could even be in the same directory. And so what happens is, if I delete either one of those hard links, the original file still stays there on disk. So it's very complicated. It's kind of tricky and pretty cool, actually, that you can do this in Linux. Now, all links are created with the ln command, or link. Symbolic links will show up with the ls command. So, like I said, it's a little file out there. Where hard links will be an identical file, but the link count will be increased. So let me show you what I'm talking about with links and how these work. So I'm going to go back here to my Linux workstation. I'm going to open a terminal window. So I'm here in my home directory, and I want to demonstrate to you how links work. So if I type ls-l, notice here that there's a file called install.log. What I'm going to do is create a symbolic link to this file. So if I type ln for link, -s for symbolic, then I type the name of the original file, which is install.log, then I type the name of the symbolic link I want to create. So I'll call it sym install.log. Okay, I just created a symbolic link. Let me hit up arrow twice and do a ls-l again. And you can see, here's my symbolic link. It's called sim-install.log, and it redirects it. It's a shortcut that points to install.log. And if you look over here in this column, you can see that it's an L. Its type is an L. So it's not a regular file, it's a link. It's a symbolic link. And you can tell that by this little arrow here and also by the L. Symbolic links are going to have that L and this little arrow that shows you where they point. Now, with symbolic links, I could delete this install.log, and just like a shortcut in Windows, the shortcut would still exist here. This symbolic link would still exist. So it's just a pointer. That's all it is. And I can remove it with rm and I deleted it. So that's how you create a symbolic link. Now let's create a hard link. So if I type ln without the s, I type the name of the file, and then I type hard install.log. Okay, I just created a hard link. So let's do ls-l. And if we look here, here's this file called hard install.log, and notice it's the exact same size as the original install.log. And if you look at this column right here, see this 2 and this 2. What this column is the number of hard links that point to this file. So this one has 2 and this one has 2. That's because there are 2 hard links. There's this one, the one I made, and then there's the original. So that's how they calculate 2. If I type ls-li, I can see the inode numbers. The inode numbers are over here. So on the hard-install.log file, here's the inode number, 391683. If you look over here at the install.log, notice it's the exact same number, 391683. That's how you know that these two are hard linked to the exact same file. So if I were to delete either one of these, the file would still exist out there. And these inode numbers are unique. There shouldn't be, or there won't be, any other file on this Unix server that has this exact same inode number. So that's how links work. They're pretty amazing, pretty cool, and the operating system actually uses hard links a lot for directories and certain files. It's very interesting. So with that, let's close this out and let's go back to our slides. Okay, we talked about links, so now we can move on to securing files and directories. Now, securing files and directories in Linux, of course, just like any other operating system, is a very important aspect of the operation and administration of the file system. And Linux Plus Objective 2.6 covers this. They say you need to know how to modify file and directory permissions and ownership, and it says, for example, you need to know the change mod commands, change own, sticky bit, octal permissions, and change group. These are all CLI commands. So first off, I want you to know that you have a user ID and a group ID. Every person that logs into a Linux server has a user ID and a group ID. And that user ID uniquely identifies the user who's logging in. So in Windows, they have the same thing. They have a ID that identifies every user in Windows. And it's unique for every user. It's called a SID. So another thing you should know is that files you create are associated with your user and group, and permissions are based on your UMask. UMask is something that's set when you log into a server. And that UMask determines what the permissions will be on any new files that you create. And we're going to learn more about UMask in just a minute. Now, every file has permissions associated with it. And when we were over there doing ls-l, you saw the owner, the group, and then the permissions. So we'll go and we'll look at the ls-l output and see how that works. We'll see the owner, the group, the file size, the creation time, and the file name. And we're going to look at the file type code, especially on the ls-l. That's that far letter on the left when you do an ls-l. So normally there'll be a dash there, which just represents normal data. A normal file has a dash. Could be a program even, but it has a dash. A D has a directory. An L has a symbolic, means that it's a symbolic link. A P is a named pipe, and named pipes are for program communications. An S means that it's a socket, and a socket is for network communications. A B is a block device for disk drives, tape drives, or optical devices. And you see these last few types, the P, S, B, and C, you'll see these in the dev directory. If we go in the dev directory, you'll see those. And then a C is a character device for parallel or serial ports. Now, permissions in Linux can be represented in octal, the octal numbering system. They can also be represented by letters. And earlier in one of the videos I showed you how the permissions in Linux are in little groups, and you have read, write, execute for user, read, write, execute for group, and read, write, execute for other. They can also be represented by numbers, and those numbers are in octal. So what you do is you add up the numbers for each permission. So execute is 1, write is 2, and read is 4. So if I wanted read, write, execute for user, group, and other, I would add these three numbers up to get 7. 1 plus 2 plus 4 is 7. So that's a 7 right here. That 7 represents user. The next 7 represents the group, and then the last 7 represents anyone else or other. So for the user has read, write, and execute. For the group has read, write, and execute to the file. And for anyone else, they have read, write, and execute too. So if I were to change the permissions on a file to 700, that would be read, write, execute for the user because it's a 7 at the start. Then the group would have nothing because there's a 0, and everyone else would also have nothing. So that's how the octal permissions work. Here's another example. Say that you have 644. What does 644 give you? I'll give you a second to think about it. Well, here's the answer right here actually. The 6 adds up to be 2 plus 4 is 6. So that gives you read and write for the owner. And then the 4 and the 4 of course represent read, so the group gets read and everyone else gets read as well. An important command in Linux in changing these permissions is chmod. Some people call it chmod. But chmod is used to set the permissions on a file. Change own or change owner changes the owner of a file, and change group changes the group file permissions. So what we're going to do now is we're going to go into Linux and you're going to see how these work on the Linux server. So if I open up a terminal window, first off, let me do an ls -l. And so let's just explore this a little bit. First off, you have in this column the owner. This is the owner of this file, root. Root is the owner. The next column is group. That's the group that this file belongs to, a group of users called root. This is the file size. And then this is the time that the file was created, the date and the time. And then of course this is the file name. Over here are the permissions. So the file type code is this little dash here at the start, or the D. So we talked about a D means directory, L is a symbolic link, P is a name pipe, S is a socket, B is a block device, and C is character. Let's go into dev, cd/dev, and do an ls -l. And here you'll see a lot of those different types of devices. Notice here's a character device. It's a VCSA5. There's lots of different types of devices, and it's hard to even really fully understand what all of them are. But that's a character device, I know that, because of the C that's right there. Here's a block device. This is SDA2. It's a disk. Here's an L, symbolic link. You can see the little arrow over here, and the L, that tells you that's a symbolic link. Let's see if we can find any others in here. Here's a P, that's a named pipe, init control. So there's a lot of different types of type codes, and you'll find a lot of them in the dev directory. But primarily you'll be working with regular files, which would have a little dash, or a D, which would be a directory. So let's go back to our home directory and do an ls -l again. So we talked about permissions. Let's try to change some permissions on some of these files. So here I have an install.log. Notice the permissions on it are read, write, read, and read. So in octal, that would be 4 plus 2 is 6. And then the second column would be 4, and the last column would be 4. So that's how those permissions work out in octal. So with the chmod command, I can change the permissions on that file to whatever I want because I'm the owner. Only because I'm the owner can I change the permissions on a file. So chmod, let's say 700 on install.log. So I just changed the permissions of that file. Let's do up arrow twice. And we can see here what that command really did. It made it so that only the owner has read, write, execute, and no one else has any other permissions. Now, execute's only needed if this is a executable, like a script or a binary. This isn't a script or a binary, so it really doesn't need executable. You couldn't really execute that. Now, with ChangeMod, I can also use the lettering system. So I can do ChangeMod G+R install.log and do up arrow twice back to ls-l. And notice I just added for the group here, I just added read. So look at that. There's the R that I just added. I can also take it away. So I can do ChangeMod user minus execute. So I'm going to take off the X right here on the execute permissions for me, the user. So there you go. We just took off the X on the install.log. So that's how you change permissions using the ChangeMod command. Now let's try to change the owner. I'm going to clear the screen. So I'm going to type change own, or CHOWN, change owner, and then I'm going to put the name of the new owner that I want to assign to this file. So the new owner is going to be Jim, and then the name of the file, install.log. So when I press enter there, I just change the owner of the install.log file to Jim. So if I do an ls-l, you can see here that Jim is the name who owns that file. Jim is the person that owns that file. So now I want to change the group. Let me change the group from Ben to Jim. So if I do change group, Jim, install.log, and do ls-l, you can see here that the group is now Jim. So that's how the change own and change group commands work. And notice over here how the permissions match up with the group, and how these permissions here match up with the owner. So whoever's in the Jim group can read the file. Whoever is actually Jim can read and write the file. But no one else can change that file except for root. The root user is all powerful. Another thing to notice is up here, this was our hard link that we created to the install.log. Notice how the permissions up here changed too. The owner changed to Jim and the group changed to Jim when we changed the permissions down here on the install.log. That's a very interesting thing about hard linked files. Since they're really pointing to the same file, the permissions have to change on the hard link just like they change on the other file. So if I were to change the hard link, it would go back and it would change the install.log. So that's the change own and change group command. And we learned about the change mod command. And the change mod command has recursive options so that you can go all through different subdirectories and change permissions. So I think that's a good overview for how to secure files and directories in Linux. So with that, let's go back to our slides. And we can move on to our next topic, which is permissions. So now we're going to talk about permissions. Permissions are very important in Linux, just as they are in any other operating system. We just finished talking about how to secure files and directories. So now we're going to talk about setting the default permissions for a file. Now Linux Plus Objective 2.7 says identify and modify the default permissions for files and directories using the umask command. That's what we're going to be talking about and using in this demonstration. So it's important to note that umask modifies the default permissions for files and directories. So when you create a new file, what will the permissions be on that file? Well, that's determined by the umask command. So let's scroll down here, and I put up a couple questions first off. The first one says, what is your current default permissions? Well, how you found that out is, I put it in parentheses here, a little hint, umask. UMask is what tells you your current default permissions. And then how do you set your default permissions? Well, another hint is UMask. UMask is what you also use to set your default permissions. UMask defines what permissions in Octal cannot be set. And that's important, cannot be set. So UMask is like a wildcard mask, if you're familiar with a wildcard mask. Basically it means it masks off anything that cannot be set, and whatever is left is what is actually set. UMask stands for User File Creation Mode Mask. It's usually set in the login script. Every user has their own login script, so UMask would be in there and it would define their default permissions. It's the inverse of the normal octal permissions. So whatever the normal octal permission is, UMask takes away what cannot be set, and then whatever is left is what's actually set. UMask minus capital S shows you your UMask in symbolic form. So when I say symbolic form, I'm talking about the user equals read plus write. So read plus write, this notation here is what they call symbolic form. The octal permissions are the numbers like 666 or 777 or 642, whatever it is. Those are the octal permissions. Now Fedora Linux removes the X permissions, or the execute portion of the permissions. So the execute in octal is the 1, right? 1 was execute. So even if you put in 777 as the UMask, that's the same as 666 inside Fedora. So it actually removes the 1 if the 1 exists, or if you add the 1 on there, it knows and it just takes it right off. Because execute permissions can only be manually assigned. They can't be automatically assigned or defaultly assigned with the UMask command. So some common UMask values would be, let's say 000. If you had that set as your UMask, that would mean full access, which is really read and write, because full access according to UMask is just read and write, it's not execute. So full access to everyone, or the same as 666, right? Because you didn't mask off anything, and the default is 666, so 666 is left when you're done. Another one would be 006. That means full access, or I'm sorry, no access to other, but full access to user and group. So that would be the same as 660. Let's try another one. Let's look at 022. So if you had 666 and you subtracted 022, you would get 644. So the 644, the 6 means read, which is 4, and 2, which is write. So 4 plus 2, that's how you get the 6. And then 44 means read and read, right? Or correct, I should say. 4 and 4 means read for both the group and the other. So the user has read and write because they have the 6. And read is 4, write is 2, 2 plus 4 is 6. So let's look at another one. 066 would mask off the 6, or it would leave the 6, and then it would mask off everything for group and other. So that would give you 600, which is full access to the user and no access to group and other. So normally you can just subtract from 666, but be very careful as to what version of Linux you're using, as it may be 777. In Fedora Linux, it's 666, but let's test it out. Let's see exactly how it works. So I'm going to open a terminal window, and first let's see what our default permissions are set at using UMask. So if I just type in UMask, it tells me in Octal what my default permissions are. And it tells me 0022. Well, this first 0 here, you can ignore that for now. Just the first 0. just look at the 022. Okay, those are your permissions there. The first 0 is the mask as it relates to the sticky bit, the set UID bit, and the group ID bit. And we're not going to get into those right now, but we will talk about them in future videos. So just look at the last 3 digits right now. So say our mask is 022. If we had 666 and we subtracted 022, we would get 644, right? So our default permissions should create read and write for the user, and then read and read for group and other. So let's try that out. Let's see if that's really the case. So I'm going to echo hello, and I'm going to create a new file called hello. So I just created a file. Let's do ls-l and look at the permissions on that file. So here are the permissions we're looking at. So it did create 644. So 6 is read and write, and then 4 for read and 4 for read, 4 for group and 4 for other. So because of our UMask, right, that's how we ended up with these permissions right here. So if that's really true, let's test it out. Let's change our UMask, and let's make our UMask 066. So now if I remove that file, and then I create a new file, and I do an ls-l again, look at our permissions now on that file. Read write for user and nothing for anyone else. So that's because of the UMask we set right here. This 066, that set our UMask to 600. So when I created this file, it's read write for user and nothing for anyone else. So that's how UMask works. And I did say that if you do UMask minus capital S, it tells you your default permissions in symbolic form. And even though it tells you that X or execute is part of that, it's not. The Fedora Linux operating system just takes that off. So let's go back to our slides. And we completed our little discussion on UMask and how UMask works. So now we can move on to configuring X Windows. Now Linux Plus Objective 3.11 says configure the X Windows system. So that's a very generic, very open-ended requirement of the Linux Plus exam. But we're going to try to fulfill what you need to know about that to the best of our abilities. First off, I want you to know that Linux has an X Windows server. X Windows works off of a client and server concept. So when you look at the GNOME environment over here, the graphics, when we look at this, all these graphics and these windows, and you can move the windows around and minimize them and open them back up and open new windows. This is all part of X Windows. You know, it's called GNOME, the desktop window manager is what you're using here, but it's part of the X Windows system. So X Windows is a client and server application. You have to run an X Windows server on your Linux system, and then these little applications you start up in the Windows, those are X Windows clients. So they're talking to the server, and through the server, that's how they're running. Now you might be thinking, well, that's kind of weird. I mean, I'm doing this all on one PC or all on one server. Why do I have to have this server and this client? You know, why can't I just run the application like you do in Windows? Well, X Windows was originally designed for large mini computers running Linux, or Unix, excuse me, and then they would have X Windows terminals, which would be sort of dumb terminals, many times without a hard drive even, and they're just graphical devices that talk to the X Windows server running on the Unix system, and the X Windows server and the Unix system actually run all the applications for them. So those X Windows terminals out there are just displaying what the computer sends them, and then they're sending back the keyboard and the mouse commands back to the Unix server or the X server. So this is very similar to how Microsoft Remote Desktop works, right? If you've ever used that, you're viewing an application that's actually running on another system. So that's what X Windows does. It was the original way of doing that. So this concept of having an X Windows server and client, even if you just have one PC, you still run the X Windows server and you run the X Windows client in the form of your applications. There are two different X servers that are common out there. One is x.org-x11 and the other one is x386. Your X server must support your video card. If not, you can use a frame buffer device. It's a way around it, but it doesn't give you as good a graphics. You could use another X server. Basically, you have another server running X Windows. Or you replace the hardware, get a new video card. And that's probably the best option if your video card really doesn't support it and you really want to run Linux. Of course, an X server is installed by default. Fedora 5 uses Xorg X11 version 7. To configure X server, you'll have to change to a mode where the X server is not running and use the command line. To do this, you can do telinit 3. So this changes the mode of the Linux server so that it gets out of a graphical mode and goes to a text-only mode. Once you make your changes, you can do start X to manually start the X server, see if your changes worked, and then hopefully go on from there. Running the telinit 5 command will put you back into the graphical X Windows mode. You can manually edit the xorg.conf tool or use graphical tools. So you can modify this file, and we're going to go in and look at that file. So let's take a look at it and just see how the file is laid out. We're not going to be making changes to the file and stopping and starting the X server and all that kind of stuff. I just want you to see the file, just see basically how it's laid out. And then also we'll look at the graphical tools so you can see the changes you can make there. So back here on our Linux server, I'm going to close out our command line for now. And let's go up to System and go to Preferences. And in here, the different X Windows settings are sort of mixed in. It varies. Like here's set your window properties. Well, that has to do with the X Windows system. Select windows when the mouse moves over them. Double click the title bar to perform an action. Movement key, different things like that. These all relate to the X Windows system. Even your resolution and your colors. Screen resolution here, the refresh rate, even these are X Windows settings. So most of the settings you find up here in Preferences are actually X Windows settings, and they're actually changing the X Windows configuration file, text file, when you change the settings up here. So let's go take a look at that text file. Alright, so the text file is called xorg.conf. So where is xorg.conf? Well, let's say we don't know. We want to find it. So I'm going to use the find command with the print option. I'm going to pipe it to grep and look for xorg.conf. There it is right there. Found it right away. I'm going to do Control-C because we already found it. So we used one of our tools here that we learned about in this video, taking the output from find and piping it to grep to find the file that you're looking for. So I'm going to cd into etc. I'm going to cd into x11, and I'm going to use more to look at the xorg.conf file. So this is our xorg.conf file. This is what is used to configure just about everything you see in the windowing environment. Even though it says x386 up here configuration, this is actually xorg x11. If it were x386, it would be named with a different name. The name is like xf86. So if you scroll through here, be very careful if you ever edit this file, because one wrong change in here and a reboot and your X window system won't work anymore. You'll lose your graphical environment with a mistake in this file. So we're not going to make any changes. We're just using more. We're just scrolling through here and looking at how the file's laid out. So notice that there's the concept here of sections. So notice this starts out section files, and then it has a configuration line, and then it has an end section. So that's how it's laid out. Every area has its own section and then end section. So we're just going to scroll through here and look at the different things it does. So for instance, here's input device. So that could be like your keyboard or mouse. We scroll through here, there's more input device. Here's video card. So here's the video card I'm using, VMware Inc. PCI display adapter. So like I said earlier, you have to make sure that your video card is compatible with the X window system. If not, it's not going to work. Here's my monitor. Here's my screen. Here's my resolution, 800 by 600 or 640 by 480. And that's the end of the file. But it's just important to know that the file's organized in sections. It has lines for your video card, your monitor, keyboard, other things like that. It's located in /etc/x11, and it's called xorg.conf. So let's go back to our slides. So we learned just the very basics about configuring the X Windows system. You know, it's obviously easier to do it in the graphical configuration mode using, you know, the graphical tools. You can point and click. It's a lot easier than editing a file, but you can do it either way in Linux. So with that, let's move on to our next section. Now we're going to talk about environmental variables. No matter what prompt or command shell that you're at, there are variables set behind the scene that can control things in your environment. So these variables are fields that have values. And I think the best way to understand this is just to look at the different environmental variables. For instance, the first one that we're going to talk about is path. Path is your search path. So whenever you type the name of a program, say I type ls to list out files, it searches the directories that are in the search path for the ls command. So if the ls command isn't found in the search path, then it'll say no such file. So let's look at how the search path works. So I'm going to clear the screen here. So I'm going to change into my home directory by typing CD. I'm back in my home directory. And I want to show you right now what the path variable currently is. So I'm going to do echo $, capital path, P-A-T-H. And that's how you show what a variable is, or you have the operating system display the variable by saying echo, and then the $ is what tells the operating system that a variable is about to follow, and then the variables are usually uppercase, and uppercase and lowercase are different. So this is the value of our path right now. All these directories are what's searched whenever I type a command. So if I type ls, it just went and found that command from one of these directories. It searched through all those directories and said, oh, here's the ls command. Then it found it and it used it. So if I type where is ls, it tells me where the ls command is. The ls command is stored in the bin directory. So that bin directory must be part of my path. And here it is up here, part of the path, /bin. So that's how the operating system finds the ls program. Searching through the path, it gets to /bin, it says, oh, there's ls, and it runs it. So say I created a new program that I wanted to be able to run. Say I copied /bin/ls into my current directory, and I called it my ls. Okay, so now I have this program called myls in my current directory. I'm going to do an ls-l, and you can see myls is right here. Notice it's an executable and it's colored differently. So if I type /myls, I just ran my very own ls program. So I copied one of the system binaries, I put it in my directory. But if I just type myls, it says command not found. And the only way it worked just a second ago is I told it exactly where it was by saying /. / means in the current directory run myls. So I explicitly told it where to find that program. But say I wanted to be able to go to other directories and I didn't want to have to always specify exactly where myls was. I want to append my home directory to my path statement. So how I do that is I modify the path variable. I do echo, I do path. I'm going to redefine the variable with path equals $path colon /root / just like that. Okay? So what I'm doing here is the path variable, I'm redefining it. I'm going to say it equals $path. So that's the current path statement. All those statements we saw up above, all those directories, I want to add my new directory onto those. If I didn't put this $path in here, it would just replace all the directories already listed with the new directory that I just put in. So I don't want just that directory, I want those directories plus my new directory. So if I put that on there and I add on my directory and it's separated by a colon, I press enter. Now I can echo $path. Okay, and notice here's all the directories that were there before, and here's my new directory /root. That's my home directory. That's where my new command is. My ls command is located there. So now if I just type myls, it works. So I can go anywhere. I can go into cd etc and I can type myls, and it does an ls command, and it's getting that myls from my home directory where I put my own copy of the ls command. So now you see how the path variable works. An important security concern you always want to watch out for is the dot. Having the dot in your path is a security concern, and that's because the dot represents the current directory. So say you had dot in your path. If I had dot listed in here, that would mean the current directory. So whenever I ran a command, it would look in the current directory that I was in and try to run that. Or it would look in the current directory for the program I was trying to run. And this is a security concern because, as you can see, it's very easy to copy the system executables and make your own. So if I were to copy the system shell, let's say, like the bash shell, and I made it set UID to a certain permissions, and I put it in, I had the dot directory in my path, and someone bad had put a copy of the bash shell out there, and I accidentally ran it as root, or ran some other script as root, when I really thought I was running a different program, I might unknowingly run what they had put out there maliciously. So it's kind of complicated, I know, I'm sorry, but the important thing is having the dot in your path search list is a security concern. So although it might be convenient, you don't want to put the dot in your path as a directory to be searched for executables because it's a security concern. So let me clear the screen, and let's just go through some of these other variables that were on our list. The next one is display. I'm going to echo display. Now the display is where do you want default X-window client windows to pop up at. Usually it's 0:0. 0.0, excuse me. 0.0 represents the current window right here that we're looking at. So when I open a new X Windows program, I just want it to come up on the current window. Now you might have another X Windows client that you want things to pop up on. So that's what the display is for. How about the term type? Echo $term. Right now my term type is set to Xterm. That's the type of terminal I have here. I have an X Windows terminal. There's many other types of terminals, including dumb terminals that just have ASCII based text on them. A lot of companies still use those dumb terminals, and they have their own terminal emulation types. So if you're on one of those terminals, it's very important you set your terminal type to match the terminal that you're on. If you don't, you're going to get all sorts of gobbledygook on your screen, and it's going to be very hard to use it without the right term type. So that's what the term variable does, is it sets your terminal type. Alright, how about PS1? So PS1 is my prompt, and this is kind of weird here, but this represents my username, my host name, and then the folder that I'm currently in. So that's what this represents. But by changing PS1, I can change my prompt. So if I say PS1 equals Big Sky Fishing, I just changed my prompt to Big Sky Fishing. So you can change your prompt whatever you want. It's a user, configurable setting. That's what PS1 does. It's your system prompt. Okay, how about the user variable? $user tells me the name of the user that I'm currently logged in as. How about home? Echo $home. $home tells me my home directory. So one way to see all the variables you have set is the set command. So I'm going to type in set, and here's all the different variables. Some of these are user configurable, others of them are set by the operating system, and they're used for just certain weird things. So here's my PS1 prompt that I set there. Here's my default shell. Here's my user ID. Here's my term type. Here's my path. There's the path that we set there. Here's where my mail goes. Here's LS colors. This is what determines what file types will be set at what color when you do an LS. The host name, local host name of this server, my home directory. There's so many environmental variables that are set. Here's where the history of my commands go, and how many commands will be stored in there. Lots of environmental variables. So that's how you see what environmental variables are currently set. And different shells use different environmental variables. And different shells have different ways of showing you what environmental variables are set. Like in the C shell, you use the setenv command to show and set your environmental variables. So one last thing on environmental variables, and then we're done on this topic. What does exporting an environmental variable do? Well, what an export does, when I type export $path, export path, like that exports the path variable so that if I start up another program, it has access to that same variable. So exporting a variable is important if you want other programs that you start to be able to use that same variable. So that's what exporting does. So I'm going to close out this window here, and let's go back to our slides. Alright, well, we've reached the conclusion of this video, video number 5. In this video we learned a lot about how to use Linux. We learned how to create and modify files and directories. We learned how to search using things like find, grep, locate, where is, and other programs like head, tail, more, and less. We learned about linking, the difference between hard links and soft links or symbolic links. We learned about ownership and security. We learned how to use changemod to set permissions, either in symbolic form or in octal. We learned about change own and change group. We learned how to see what permissions are currently set and what the current owner is and group is using ls-l. We learned how to set your default permissions for file creation with the umask command. We know that a file in Octal with permissions of 4 would have read permissions, a 2 represents write, and 1 represents execute. We learned how to configure the X Windows system using the xorg.conf file, and how the xorg.conf file is broken up into sections, and those sections have a start and an end. And how important it is to have the right graphics card that supports your X Windows server. X Windows uses a client and server concept, so normally in Linux you have the client and server running on the same system, but it doesn't have to be that way. We learned how environmental variables are important to your shell and what programs you're able to run. We learned how to modify environmental variables, show environmental variables, and export environmental variables. So with that, we've reached the end of video number 5, Using Linux, Part 2. I hope you've learned a lot about how to use Linux, and I look forward to our next video. Thank you.